Hello class, welcome to your second video on geometric sequences. Today we're going to talk about the learning targets. I can find indicated terms of a geometric sequence. We're going to do that by finding some specific term using a formula. We're also going to learn how to use the geometric mean to find missing terms of a geometric sequence. And also we're going to talk about the explicit formula of geometric sequences. So we'll talk about explicit formula. So taking a look at this first example here, we just continue with where we were in our notes. What are the indicated terms of this geometric sequence? We were given the term 2, and we were given the term negative 54. We have two blanks here. I'm going to have to find the second and third term. So first of all, I'm noticing I've got a positive here, and I have a negative. So my mind is thinking, this must alternate positive, negative, meaning that R, the common ratio, is going to be some negative number. So let's take a look at the geometric sequence formula. It says AN equals A1 times R raised to the n minus 1 power. Here, I could say that my first term given, A1, is 2. So I can substitute that value into the formula. I could say that AN is the last term that I'm given, negative 54. And I could say that if this is A1, this missing term is A2, this other missing term is A3, this AN that I found is actually A4. This is the fourth term. So therefore, N is 4. What I don't know is what is this common ratio. All I know about it is that it must be some negative number. So I'm going to do some solving. So let's take what we have, negative 54 equals 2 times R raised to the, I'm going to change the 4 minus 1, substitute that expression with 3, or simplify that expression. Okay, I know I want to find out what R is, so since multiplication is what is separating the 2 and the R to the third power, I'm going to cancel the 2 by dividing both sides by 2. So I have R to the third power is equal to negative 54 divided by 2, which is negative 27. So I need to find out what R alone is. So to do that, I need to undo R to the third power by taking the cube root. So on your calculator, if you will push math and then look at the list, the fourth choice says cube root. Then I'm going to type in negative 27. So I find that the cube root of negative 27 is negative 3, meaning that R, we knew it was some negative number, R is negative 3. Once I know what R is, I can go back to my sequence and fill in these missing blanks by multiplying by negative 3. So 2 multiplied by negative 3 gives me negative 6. And negative 6 multiplied by negative 3 gives me positive 18. And 18 multiplied by negative 3 gives me the negative 54 that I see last. So the second and third terms are found by finding R using our formula. The next question says to find the second term of this sequence, 33 then something, and then 297. We could go through the same procedure that we used the last time by saying A1 is given to be 33, A3 or AN is given to be 297. Solve for R. So to do that, using the geometric sequence formula, AN equals A1 times R raised to the n minus 1. Replace AN with 297. Replace A1 with 33. We do not know R, but we do know that 297 was the third term of this sequence, so n is 3. Simplify. That gives us 297 is equal to 33 times R to the 3 minus 1. We replace or simplify that expression to be 2. And then we think about the fact that 33 is being multiplied by R squared. So to undo multiplication, we divide both sides by 33. And cancel using division. That leaves me with R squared is equal to 297 divided by 33 is equal to 9. Now to undo R squared, we will take the square root. Now last time we took cube root because R was raised to the third power. This time it's going to be the square root because R is raised to the second power. So I'm going to type in the square root of 9, and I get that R is equal to 3. However, I do know that in geometric sequences, if R is a positive number, I'm going to have a positive, positive, positive here because all the terms of the sequence would have the same sign as A1. But if R happened to be negative, then the signs would alternate, positive, negative, positive. And since the second term is unknown, we could actually have a positive or a negative term here. We don't know if R is positive or negative. And I want you to think about the fact that when you take the square root of 9, that 3 times 3 equals 9. So yes, the square root of 9 is 3. But also, negative 3 times negative 3 is 9. So the square root of 9 is also negative 3. So we'll say that R is plus or minus 3. It could be a positive common ratio or a negative common ratio. So when I have to find the indicated term here, my R could have been positive or negative 3. If it were positive 3, then 33 times 3 would give me 99. And 99 times 3 would give me 297. But if R were negative 3, then 33 times negative 3 would give me negative 99. And negative 99 times negative 3 would give me positive 297. So we will say that this missing term is actually plus or minus 99. That means there's two possible correct answers. And we indicate that with this math symbol called the plus or minus symbol. Because there was only one missing term here, there is a second way that we could have found the missing term. Because there was only one blank, or because there was an odd number of blanks, because there is a middle. If you remember, when we found missing terms in arithmetic sequences, we found the arithmetic mean to find the number in the middle. And that meant we added up the two numbers we had, and we divided by 2 to find the middle number. Well, there is something called the geometric mean. I want you to write this down. Geometric mean. So we could have found here the geometric mean by, here's the procedure, taking the square root of the product of the two numbers given. And the answer for the geometric mean is always going to be plus or minus, a positive or a negative. So let me demonstrate with the problem we were given. When we had A to be 33 and B to be 297, we could have said plus or minus the square root of 33 times 297. So at this point, you could just type in the calculator, leave the plus or minus portion off, but you could type in exactly what you see highlighted here. The square root of 33 times 297. And the square root of 33 times 297 is exactly 99. But you have to know that the terms could be alternating signs, or they could be all the same sign. So you get plus or minus 99. This is the procedure for finding the geometric mean. Be sure you have that in your notes. Okay, now we're looking at a reading problem. But you're going to find that the reading problems here are really not very bad. This says that when a ball bounces, the heights of consecutive bounces, that means bouncing one right after the other, the heights of consecutive bounces form a geometric sequence. What are the heights of the fourth and the fifth bounces? Well, from the diagram here, we see that the height of the first bounce is 100 centimeters. And we see that the height of the third bounce is given to be 49 centimeters. I don't know the height of the second bounce. So that is unknown. Well, using the process of geometric means, I could take plus or minus the square root of the product of the first and third bounces, 100 times 49, to find the height of the second bounce. So do that on the calculators now. You're going to type in square root of 100 times 49. And I got 70. So if we're talking about the geometric mean here, the geometric mean is plus or minus 70. However, when we're talking about how high a ball bounces, I do not believe that it is possible for a ball to bounce a height of negative 70 centimeters. So we're going to discard the negative portion here, and we're going to say that the second term, A2, is a height of 70 centimeters. Now that I know some consecutive terms, that the first bounce is 100 centimeters, the second bounce is 70 centimeters, the third bounce is 49 centimeters, I should be able to find R, the common ratio. So let me write out the terms of the sequence here. It's 100, then 70, and then 49. So through division, I'm going to divide 70 by 100, and I get 0.7. And I'm going to divide 49 by 70, and I also get 0.7. So R, my common ratio, is 0.7. The question asks me to find the heights of the 6th and the 10th bounces. I could do this two ways. I could extend the pattern. I could say this is A1, A2, A3. I could find A4, A5, A6, A7, A8, A9, A10 by extending. Or I could very quickly use the geometric sequence formula, which is what I'm going to demonstrate. AN equals A1 times R to the n minus 1. So, if I want to know the height of the 6th bounce, I'm looking for A6, where A1, the first bounce height, was 100 centimeters. My common ratio we've determined is 0.7, and I want to know the height of the 6th bounce. I substitute in 6 minus 1 for n, or 6 for n. So putting this into the calculator, 100 times 0.7 raised to the power of 6 minus 1 gives me a 6th bounce of height 16.807 centimeters. To find the height after the 10th bounce, on the 10th bounce, I find A10. So that's 100 times 0.7 to the 10 minus 1. So the height of the 10th bounce, I'm going to substitute this into the calculator. I get 4.035, and I'm going to stop there. Approximately 4.035 centimeters. So what we find is the bounce height of the ball gets smaller and smaller. We are not surprised by that because we have a common ratio that is less than 1. It's a decimal, 0.7. So the bounce height should be getting smaller and smaller by 0.7. Okay, the next question is asking us to use that geometric mean that we found. So we're going to use that formula, geometric mean. The square root of the product of 48 and 3. So the square root of 48 times 3, I can input that to the calculator. I get 12, but remember, it's always going to be plus or minus. Number 19, I want you to try this on your own. I'll pause the video, and I want you to try to calculate the geometric mean on your own, please. So when we calculate this geometric mean, we should get 90, but please remember that it's always going to be a plus or minus, because the terms of the sequence, if r is positive, they're all going to stay the same sign. So it would be positive 18, positive 90, positive 450. Or if r were negative, you would have positive, negative, positive. So be sure that you think about the fact that when you find geometric means, we're always going to get this plus or minus. Again, find the geometric mean. Try this on your own, please. So I hope you got plus or minus 65 for the missing term. Okay, that ends what you see on your notes, but there's one last thing that we wanted to talk about, and that is our explicit formula for the nth term. In order to write an explicit formula for the nth term, just like when we wrote explicit formulas with arithmetic sequences, we need to know two things. We need to know A1 and we need to know R. In arithmetic sequences, we needed to know A1 and we needed to know D. So let's do an example here. Let's pretend that A1 is 3 and our common ratio is the number 2. And I want you to come up with an explicit formula for the sequence that this represents. So we'll begin with the the geometric sequence formula. AN equals A1 times R to the n minus 1. In order to come up with an explicit formula, the process is very easy here. We're going to replace our A1 with the given number 3. We're going to replace our R with the given number 2. And to find the explicit formula is defined to be a formula for the nth term, or for any nth term of R. The explicit formula is this right here. You just substitute for A1, substitute for R, leave n in the problem. So this is defined to be an explicit formula for the geometric sequence that has a first term of 3 and a common ratio of 2. I hope this helps you to understand your homework, and we're going to have some time to work on homework now in class, so good luck.